And while people are joining, before we get started, we have a sort of a pre-webinar chat topic. Yolanda, would you mind forwarding one slide, please? And our warm-up chat here, while people are still joining us, that we invite everybody to enter something into the chat as you'd like, think about one skill that you've developed that could transfer to a different field than what you are in or what you were planning on being in. One skill that you've developed that is easily transferable to a different field. Everyone is welcome to think and start typing. This one, we invite all of our participants to think and add on. What's a skill that you've developed that could be transferred to a different field? And feel free to enter your thoughts into the chat as soon as you're ready. And so Elena says the ability to research a topic thoroughly. Louisa, yes, presentation and writing skills are excellent skills to transfer and really fundamental for doing science as a general rule. So yeah. What other skills do people have that could transfer to a different field? Geological investigation. Thank you. Thank you, Maj. Learning to be an extrovert. Those of us who are, de facto introverts, working on that. Curiosity, interpersonal relationships, GIS skills, chemical analysis. So useful for so many different fields. Computer programming and scripting. Thank you, Nick. Yep. Critical skills for so many different fields. Networking. Networking is so fundamental to so many skills. If you have an answer, please do enter it into the chat if you're able to. We are expecting a large number of people in this webinar, so at this point, I'm not planning on unmuting and inviting our participants to share their video or to share their audio at this point. So while people are continuing to think and answer, Yolanda, could you go ahead and go back to the very first slide? Angelina says problem solving. Computer science, different languages, so many different skills. Well, everyone, thank you so much for joining us today for our webinar on translating your planetary science skills. We're so glad to have all of you with us here today. My name is Christine Shupla. I'm with the Lunar and Planetary Institute. I'm joined by Yolanda. Yolanda, you want to say a word or two about yourself?
Hello, everybody. I'm Yolanda Ballard. I am a program coordinator for the education department. I work in close proximity with Christine, and I assist in all areas of whatever projects we have going on. I am the liaison between the education department and our headquarters. I've been with the LPI for 16 years now, and I'm happy to be here. Thanks.
Thank you so much. And if you forward 2 slides, we've got a little bit of information about our panelists, and we would love to have them each go ahead and say a little bit about themselves. So Nick, would you mind introducing yourself, please?
Sure. Hi, everybody. I'm Nick Schmerr. I'm a professor at the University of Maryland, College Park, in the department of now named Department of Geological, Environmental, and Planetary Sciences. We just went through a name change of our department because we wanted to be more inclusive of all the different things that the group does. I'm a planetary seismologist, a geophysicist. Have been very interested in planetary science throughout my career. I've been here at Maryland about 14 years, and a lot of my research has focused on sort of the planetary side of seismology, thinking about moonquakes and Mars quakes and asteroid quakes and Jupiter quakes and you name it. Whatever object is moving, it's something that I'm interested in. So we've been doing a lot of work in supporting how to go out and do these kinds of sciences here at Maryland. So we go out into the field, both in cold environments, volcanic environments, and basically try and understand how we can do this geophysical science on other planets. So it's been a really interesting career, and I continue to keep going out there and exploring. I'm interested in talking to you all about how you get into this discipline.
Thank you so much. Majd, I'm sorry, I see that we've misspelled your name again. Majd, would you mind introducing yourself?
No worries, yeah. Hi, everyone. My name is Majd Mayyasi. I'm a senior research scientist at the Center for Space Physics at Boston University. And let's see, I started off professionally as a computer and communications engineer, where I learned a lot of computer programming skills. And I think Nick and others mentioned in the chat how useful that skill is to translate into other careers, and I completely agree with that. I transitioned into astronomy because it's where my passion was, and it doesn't feel like work when I do that kind of stuff. I've done numerical simulations, very much leaning on my background in computer coding, and from there I learned to work with data from different missions at Mars specifically. I'm on the MAVEN science team and on the MSL science team, with the TGO science team as well, and collaborate with lots of other groups internationally as well as domestically. I'm recently now kind of diversifying into hardware, space hardware, because I understand our limitations in what we know, basically from what we can measure, and I'm looking to develop cutting-edge technology that can help us learn better and more interesting things. And I also did a couple of years of service with NASA at headquarters as an intergovernment personnel act in the science mission directorate with Planetary Science Division specifically. And that was really helpful to get to understand the programmatic side of science, where the budgets come from and how they're allocated, and generally the proposing process, the selection process, and the priorities that govern where NASA decides to invest the money. And I'm very happy to be here. Thank you.
Thank you so much. Corrine, please introduce yourself.
Yes, of course. Thank you for having me. I'm Corrine Rojas. I'm also honored to be here amongst the other panelists, and Christine, of course. But yeah, so my name is Corrine Rojas. I am a contractor for SSAI over at NASA Goddard Space Flight Center. I am a mission science operations specialist. I've been working on different missions doing science operations for over 10 years now. I started with the Lunar Reconnaissance Orbiter, working with the camera science team. So I have been following along with the Artemis 2 mission very closely, and very excited to see these astronauts talk about these craters and these sites that I helped map back when I was in undergrad. It's just, it's been so joyful. And I've also worked on a couple Mars rover missions, including Curiosity, the science team as a collaborator, and also doing science operations for the Perseverance rover, the mast cam cameras. So those are the science cameras, the two little eyeballs on the rover. And I did that for a few years, and yeah, loved it. Love Mars, love the moon. Currently, I'm back here on Earth. I work for the PACE mission over at Goddard. It's plankton, aerosol, cloud and ocean ecosystem. So very much, lots of water, lots of life here on Earth, as I'm learning. But yeah, so a little bit of science operations it's kind of a cross between being a scientist and an engineer. So I feel like well, not only am I primarily in earth science now, but I have kind of a non-linear career path in this field, and yeah, I'd love to explore or expand on that a little bit more as we continue this talk.
Awesome. So let's find out a little bit more about everyone else who's here. We've got a little poll question here to find out more about who you are. Are you a grad student? And that could also include a postdoctoral, somebody who's in the process of getting their PhD in the final stages. Are you an undergraduate? Are you a postdoc researcher, professor, mid-career, late career, science enthusiast, educator? None of these. You're welcome to enter anything that works for you, and multiple answers. You can answer 2 or 3 things, right? Because in some cases it might be more than one of these. Let's go ahead and give everyone about 5 more seconds to finish answering who and what they are, how you want to describe yourself today, so that we have a good picture for who all's with us right now. And 5, 4, 3, 2, and 1. And so it looks like we've got a lot of graduate students, a few undergraduates and a few postdocs, some mid-career folks, enthusiasts, and a few people who really don't fit into any of these categories. So we're really glad to have all of you here with us today. This is helpful to know, though, who's here. Let's go ahead and stop sharing the slides so we can see all of our amazing panelists here. And so what we're going to be doing is talking a little bit about the ways that our panelists, our speakers, have taken their skills that they had and used them for something different, or ways that they might now be looking back on how they could have channeled and prepared. What skills do you wish you'd had developed? What skills do you have you been using and you've been really glad to have them? That sort of thing. So my first, and everyone is welcome to answer questions for our panelists into the Q&A or into the chat. I'm going to go ahead and hide my video so that I want to be able to see our panelists more. But my question for our panelists is, we started off with this question. I'd like to invite each of you to go a little bit further into your answer. What is one skill that you've developed that you were able to transfer to a different field as you were in your experiences or preparation for your career? I'm going to pick on Corrine first. Corrine, could you go ahead and answer?
Oh, of course. I was about to unmute and offer to go first. A lot of folks in the chat actually kind of nailed it, and so did Maj. So I'm sorry if I'm going to steal your thunder a little bit, but I think actually one of the most used skills of mine, if not the most used skills, is communication, especially between disciplines. That is something that I've learned early on. I actually started my undergrad in political science, if you can believe that, and I did a hard pivot. But knowing like the art of talking points, knowing how to cater your message to the person that you are talking to or the intended audience, that has been one of the most useful areas. And it also helps to evaluate what kind of communications or lack thereof are happening, and where you can, if you have the power to, be able to kind of make some connections and connect people together and yeah, help collaborate. That's been one of the most useful skills that I've been used.
Thank you. Thank you. Majd, would you like to go next?
Yeah, thank you. Yeah, there's so many skills. So Corrine, I appreciate you bringing that up. I can highlight another one, and that is just to be authentic. There's a lot of, I think, a lot of people that do really impressive work, and it's always tempting to kind of go up to them and try to impress people. But I think personally, for me, both from the earlier career person as well as the mid-career person, and in some cases, people look to me as a senior career person, which I'd love to educate them about. It's always, I think, really important to bring your authentic self to the table. Bring your authentic questions, your authentic curiosities. I've learned over time to not be shy about asking questions that I couldn't find answers to in the literature, and it took me a while to kind of just build the confidence to understand that, oh, these are actually really good questions and no one else has thought of them, or people thought they were too tricky to answer and so they ignored them. And so those actually led to many really interesting studies and investigations. So be authentic if you can, as much as you can, and do as much research as you can about stuff when you kind of consider all of these questions, and kind of stay curious throughout it. So that's on the personal side. And I think on the technical side, it never hurts to keep improving your skills, whether you have to for a particular project, or if it's something that you know is becoming more popular. Like, let's say learning Python, it's become more and more popular in the last decade or so, and it wasn't so much before that. And so if you do have computer programming skills, and you're interested in kind of staying up to date, learn the new languages that are coming up and becoming more popular. That's going to come in handy at some point down the road. And if it doesn't, then maybe learning the next language will be easier, just because you've been able to do that more than one time in your brain, and it will adjust quicker. So those are really interesting technical skills to be able to have. And if you can develop the self-motivation to do that, and if you have the time to do that, I think that would be an encouraging thing to pursue. Thank you.
Thank you, Majd. Nick, same question.
Yeah, so I mean, both all these ideas are great. One of the things when I started out in grad school is I was thinking about doing planetary science, and one of the things that was taught to me is that it's really good to have transferable skills between disciplines, right? So you can go work on a planet like Mars or the moon, or exoplanets or something like that. But this is the planetary community. Sometimes a mission is few and far in between. So the kind of research that you're doing, if it's transferable to something here terrestrial, working something on problems here on our own planet, actually gives you a lot of flexibility, right? So, an example, right? I'm a seismologist, right? So the research that I did for my dissertation and my PhD was terrestrial seismology, looking at, an abundance of data that we have here on Earth, basically learning how to do data processing with seismic data that's readily available. And then when the opportunities come to do that with Planetary, be thinking about how to transfer those kinds of skills into the planetary realm. And that way you have a way to bridge gaps between when there's actual data to work on, but at the same time be thinking about the literature and being passionate about the planetary side of things gives you an opportunity then to go and work on other planets as well. So if you're interested in doing planetary science, it's good to think about Earth as a planet too. It's something that was like advice that was given to me as a graduate student early on in my career. And I've done my best to try and transfer that so that I can actually have something to work on at all times. So you want to have something you're passionate about and knowledgeable about, which means you're going to have to spend the time digging into the literature and learning about it. But also when you're doing your degree, don't just focus on one little problem in the middle of one little tiny topic. You want to be thinking about how it fits into the bigger picture and how you can take that skill and apply it in other places. So like seismology is just an example of one discipline of study, right? But if you're doing something like mineral physics or spectroscopy, or studying composition of some particular elemental system, you want to be thinking about the bigger picture and how that you can fit into that bigger picture, I think is really important. And it's easy to get lost in the little details, but if you can think about where you're going to go with this larger tool, that can really help you build a career around it.
Thank you. Thank you. And so in general, planetary science and astrobiology you have so many different subfields. You mentioned, planetary geology, and there's a question about the skills to become a planetary geologist, which is potentially different than some skills if you wanted to study the atmosphere of Mars or the impact of the sun on and its particles on Earth or on the moon. And of course, mission work, very, very different fields. If you're, each of you has very different field work that you've done, different things. Why don't we start at just computer skills? Because there's a question in here about computational modeling, computational work. Can you each describe a little bit some of the different computer skills, the computer programs, the things that you've had to use, that you've had to develop, and nothing is off the table because some people may not realize, oh, well, yeah, that I already know that, and I didn't realize that was useful. So when it comes to computational skills, can you give us some examples of some computational skills that you've had to use or that you've had to learn?
I put that in the chat, so I'll run with that one to start. I started out in grad school learning some Unix, right? Some command line tools, basically old school, where you actually learn to interface with the computer at a very basic level and start to do scripting, right? So there's tons of resources out there for how to learn how to use some of those basic command line tools, and just navigating around the architecture of a computer can be really, really powerful, right? As an undergrad, I didn't get any training in that. No one taught me how to use a computer. I did my undergraduate training in the late 90s, so it's maybe a different world now. But actually being able to see how the computer runs and works, digging into that architecture early in your career will open up a lot of doors for you, because otherwise you're always reliant upon someone else to teach you how to use a script or how to do something like that. If you can go out and learn how to do some of those basic command line things, it can really give you a nice window into actually how to use all these other tools that are out there. So they're a little bit less of a mystery. So, dig into that early as much as you can would be my suggestion.
If I may add something to that. So I work, I do mission work, and so I work with scientists and also like the flight operations team and mission control. Something special about our little team of science operations folks is that we are also primarily programmers, so scientific programmers, lots of scripting, lots of Python. However, sometimes flight operations teams, and these are people who, send commands to spacecraft and then check spacecraft and instrument health and safety. Sometimes they aren't uh, well, aren't computer scientists, but also rely on like a distinct software developer team. So what Nick said of trying to figure out, or maybe some basic exercises, even something basic like creating a web page. You kind of do a deep dive on how either web development works, or how your Unix based computer architecture works, and that just kind of gives you an idea of what's possible and opens your mind, whether it's you kind of bringing or learning programming on the fly for your job, or just communicating with a separate uh, development team.
Thank you. Maj, do you have anything to add on to that?
Those are all great tips and advice. For me, I think I would add, because I do have the training as a computer programmer, it's super helpful to work or learn how to work collaboratively. You're not always going to be the only one running your code or using your code. Please document everything. Put little comments and say what you're about to do and why you're doing it, and put in references if you can, so that someone else reading it has an easier time of ingesting what it is that the code is trying to do.
Or yourself, right?
Or yourself, like the next day or month or year, depending on how forgetful you are. Absolutely. Yeah, I think another thing of interest is just to I think this was also a question just noted here, how long it takes to remember something when you haven't used it for a while. It very much depends on what that skill is. But learning how to work collaboratively, I think, is very important. That's, I think, just one thing to add.
Yeah, I mean, many of the codes that you write early in your career, you might be still using those 15, 20 years down the road, and either using them in the same tools that you used back in the day, or you might be using them in new ways, or somebody went out and wrote it in like the latest, Python code or whatever the code du jour is. But knowing how that code works and how to use it means that your hands aren't tied to any particular operating system, right? There are people I know in my community who use old Fortran 77 codes, and like some people are going to wrinkle their noses at that. And it's because that's all they learned, and that's the only code they know how to do this in, right? But they never sat down and learned how to do the actual programming so that they could write it in a newer language or something that would be more efficient, that could take advantage of the resources out there. So you're always forever learning in the coding world. You're never static. If you become static, then you get left behind by the community. So having good documentation so someone else can come along and help you turn your code into something that's more modern and can use the architecture of machines today, or you can update your own codes. That's a skill that is infinitely valuable. I don't know how many projects have been. I wish we could just run this code on this system rather than having to go like build an emulator and like more complicated to actually run the code than just to rewrite it, right? So those are really useful skills to know how to take computer languages and turn them into something that can actually get the work done on the computer. And it's never ending. You never stop learning. I still learn new codes every day. A little bit of coding every day for the rest of your life is my motto.
Thank you. So we've got a few other questions here. Some of them are really big questions, and some of them I'm gonna pick SJ's question next. How quickly do you use the skills that you're not using as much when you move? So if Corinne, for instance, you moved from one thing to now working with missions, are there skills that you particularly developed as a scientist that you aren't using as much? Are you worried about picking them back up when you're ready to become the next lead for a mission running, something? Maj, the same question goes for you. You've had many different positions, and in those different positions, you've had to focus on some tasks more than others, some skills. How easy or hard is it to code switch? How easy or hard is it to grab those skills back after you stop using them? Is it like riding a bike, or do you need some time to warm back up?
Yeah, I can go first. So it may be just the nature of my job that a lot of pretty much like the structure of what I do is pretty transferable. Just knowing how telemetry works, how to write programs that help analyze it, how to make data products. I will say there's a big difference between planetary science data uh, archive and earth science data. But yeah, just little details like that. But I would say if anything, something that I really learned to help me, like go back and remember is and this is pretty early on, is just taking notes. I don't think my memory is as great as a lot of people that I work with. And granted, I work with people at NASA, so but I take notes a lot, whether handwritten or on my laptop so that I can access it later, or both, right? And yeah, so that just kind of gives me insight, that and along with documentation, as much as documentation as possible.
Thanks. Sorry, I'm distracting everyone. We're trying to figure out a couple of problems with the chat potentially. But in the meanwhile, Majd or Nick, would either of you care to go next? Nick, Majd, thank you.
Yeah, sure. Let's see. There's certainly stuff I learned as a computer engineer that I didn't end up using down the road. There are things I wish I could forget that I still retain, and other things I wish I could remember that I have forgotten. But it's a lot of it's mostly like riding a bike. You do remember a lot of what you need, and sometimes it's an opportunity to learn what's changed since then. I used to forget what the different colors of resistors were. I used to have that memorized, and now I have to kind of remember it again as I build some hardware. And it's fascinating to kind of be able to rely on that kind of now ancient memory to see that it still works a little bit. But I think it's very important just to keep learning. And I think Nick mentioned this. This is actually one of the best fields I find, where you're able to continue to learn things, and if you're lucky, you'll always have opportunities to keep learning new things, and transferring from one field to another takes more flexibility and creativity than than actual knowledge. The physics is similar, really, whether you're working on Earth or Mars or an exoplanet. Physics is physics, but it's just the environment that's different, and the conditions there are slightly different. And so those are all opportunities where you can learn new things, but also kind of stay grounded in the stuff, the basics, the basic stuff that you do know. And there's no shame in looking stuff up. I don't think anyone can remember everything, and we're all, I think, very knowledgeable about a lot of things, and we're also human, and we tend to forget. So it's good to be able to resort to either notes or the internet or books. Those are my favorite. I've referred to my thesis countless times, and I'm so grateful I wrote it in the detail that I did. It's been super helpful, even though I only used bits and pieces of it, still with that same inertia. So I think those are all really good strategies to utilize.
Awesome. Thank you. Thank you. Nick, any further thoughts for you to add on that topic about being able to regain the skills that you've stopped using?
Yeah, I mean, I've done a whole lot of different things in my career. Like I worked in a lab as a mineral physicist, as an undergrad. I've done geophysics in the field here on Earth, right? And I absolutely second your notes are a treasure trove, right? You know, if you're not writing down what you're doing in the field, it's going to be lost, right? This is sort of the dogma of anybody who does field work is you just have to write everything down. And the same thing's true of your day-to-day research. If you're not keeping a research notebook or a log of the stuff that you're doing, some of your greatest ideas might get lost because you got busy and you forgot to write it down, right? So I've always like kept a little notebook. I have so many stacks of paper of just notes of things that I'm working on that day that every now and then I just go back and read and see what I was up to so I can refresh my memory on that. So, you know, we have this beautiful thing of a digital memory these days. Like there's all these great tools for helping keeping yourself organized. You know, paper is kind of old school, but like if you do have like a way to keep a digital notebook or something like that, absolutely do it. You know, this is amazing technology that we have that you can readily access, like your calendar pretty much anywhere you are, keeping track of the things that you're doing, all that kind of stuff. I mean, journaling is another thing that people do. These are all fantastic ways to sort of keep track of your evolution of your thoughts, so that you can go back and turn back the time clock and see what was it that you were working on back in April, or come up with hey, I had that great idea. What was that again? You know, you can go back and find it. So the searchable, readily accessible electronic notebook has actually been a wonderful thing where you can go back in time and do that pretty easily, rather than digging back into notebooks. So that's something that's a habit that you have to sort of develop early in your career. Because if you don't start writing things down and you just get busy, you're going to forget. There's just no question about it. I have scripts where I went back and I'm like, okay, I didn't put any comments in this. What was I doing? And then you spend more time trying to recreate the script, right? So it's something you should get in the habit of early on in your career is spending a little bit of time to document. I like to use the Artemis 2 was fantastic to watch. If you're not watching this, you should be watching this. But they are asking the astronauts to go back and take the notes, like write down their experiences so that they're capturing what they did in the field there, right? It's really important.
Yeah, I was actually gonna bring up Artemis 2 as well. The fact that they have, or like the scientists are having the astronauts go back and write the notes, and also how they feel, or like what they're personally experiencing. I think, yeah, that's just a really great idea. Something I'm learning too. And like Nick said, keeping a journal also very important. Yeah, I have like 3 or 4 different kinds of journals for different topics going around. But I did want to share for the digital part, I do use uh, apps like Notability and Notion. Those are very helpful. Those you can access like on your iPad or on your phone. And of course, there are personal notes and some work notes and school notes. But the important part is, you get to keep that. That's yours. But yeah, so and I also wanted to share that I came up with an example of something that I learned really well back in undergrad when I got my degree in geography is ArcGIS. That was 10 years ago. If you asked me to open ArcGIS and do what I was doing back then now. I don't know if I would recognize the GUI, the user interface. But since I learned it thoroughly, I can probably, after a few Google searches, I can probably figure out my way around, right? And that's kind of a good example of how important it is to just fundamentally learn something, because you can go back to it if it's Googleable. You don't have to put it in your short-term memory storage.
Thank you. Awesome points. So there's several people here who have posted questions about building a career in planetary science or in astrobiology and the skills that are needed. And of course, it depends on which part of astrobiology, which part of planetary science. Do any of you want to recommend certain specific skills that people should be focused on and be specific in terms of which subfield you would recommend those for? Planetary geology is very different from planetary meteorology, and that's very different from one type of astrobiology and a different type of astrobiology and planetary modeling. So go ahead and any thoughts are welcome. These big question.
Yeah, I mean, in any given field, there's obviously the specific skills that you'll need to be successful there. And I think that the first place anybody who's interested in starting a career in planetary science should begin is the literature. It's easy to be like excited about a topic. Like, I get excited about a lot of things, right? But until I sit down and actually start to see what people have done before me, it's just an interest. It's an excitement, right? If you really want to understand like what it is that your field of interest does, you need to go see what the technical literature says about it, right? And a lot of people discover when they start reading the technical literature, they're like, maybe this isn't for me. So I'll give a little anecdote. So when I was early career, I was really interested in dinosaurs and paleontology. I was jazzed up, like many people are, about this weird ancient creatures, right? And I sat down and I started reading the literature, and I realized that what paleontologists do is not something that I was that all interested in. It's still pretty interesting stuff, but it's not something that I wanted to build a research career about. And that only came about because I sat down and like learned about what the actual research entails. And so, but I got interested in other things by reading that literature. So I learned sort of like what it is to me was interesting enough that I was going to spend like hours, if not days and months and years of my time to sit down and become an expert in it, right? So if you're early a career and you're excited about a topic, go read some papers on it and see what they're actually doing in that literature. Like if they're in the laboratory measuring an isotopic system that requires them to do digestions with hydrofluoric acid, and that sounds horrible to you, you probably don't want to go work on isotope systems, right? Because you're going to be excited about the topic, but you don't want to do the actual work. Um, and that's totally understandable, right? Some people don't want to actually spend a lot of time in the lab. They'd rather be out in the field collecting samples or something, right? So, like, getting that sort of knowledge base of what it is that scientists actually do is really important before you actually like pick a subdiscipline. Like, you can pick anything you want that's interesting, but like see what it is that people actually do so that you can get a little bit of a better picture of this is going to be your cup of tea or not.
Thank
Yeah,
you.
I would add
Much.
to what Nick said. This is very, I think, really good advice. I would also add, especially if you're an undergrad and not yet very comfortable with technical research papers, is to see if you can find a professor, either in your university if you have access to one, or in a nearby university, and talk to them a little bit about what a typical research topic entails, and what your skills are. Come with your own skills, kind of ready to explain, and see where there's potential overlap and also room for growth. It might be a scenario where what you really have a passion for requires taking some courses, which you might be able to do in your academic career, or it might be something that you would need to take some dedicated time off to do. And again, if that's something that interests you, it won't feel like it's work. It'll be exhausting, but very rewarding ultimately. And see if there's overlap there. I think there's a lot of opportunity for cross-disciplinary work and also cross-divisional work, and a lot of A lot of folks are constantly looking to collaborate with people in different departments who have those particular skills that they don't. And so there's lots of synergies, and it helps to know what the community needs, kind of just to be able to understand what it is that's available out there. And so ask a lot of questions. Don't be shy about it, and try as much as you can to find approachable people to have these conversations with, because they might have a lot of relevant things to offer.
Yeah, and if I may add to that, well, first, depending on your stage in career, for example, you can be in an internship. I always tell people to take advantage of those internships, learn what people are doing, and if you find someone doing something really interesting, go and talk to them. Don't be shy. They are more than likely very happy to share everything about what they do. So yeah, highly recommend doing that. Or plus you can even make a new buddy, right? That, and I also wanted to point out, if you really are stuck on where to start, even looking at, sub-disciplines, I would recommend looking at decadal surveys. Planetary science has decadal survey, earth science, astrophysics. These kind of give an outline of where the field wants to go in the near-ish future. So yeah, highly recommend looking at that and seeing if any future missions kind of pique your interest and what you can do to align yourself to get there.
Thank you so much. And yeah, I'm going to post in the chat NASA science website with decadal surveys that include a variety of different ones that people might want to take a look at. So for somebody who is in planetary science and is interested in maybe working more, and some of our participants here, if you have things that you want to add, recommendations as well, if somebody has hit a slow spot or has just really decided they want to start doing some of the research support like lab work, or if they want to help with a mission, or other things like that, what are some of the steps that somebody might want to take if they're just kind of taking a slight sidestep from what they're currently doing to something that's very adjacent? Where would they start? Do you have any ideas on whether that's contacting certain people or just looking for postings or reading literature? Where does somebody start if they are looking to take a sidestep in their current position for something that's field adjacent?
Yeah, I can give a quick start. So what I did when I was ready to find other work, I did, well, using your network is really great, but sometimes that's not very helpful. Keep an eye on where these missions or this kind of work that you have in your mind, where these positions come from. For example, like ASU is a huge planetary science hub. And but if you want to do some mission work, you may be looking at JPL and Caltech or Goddard. So yeah, looking at job postings depending geography, because also there's positions that are related, but maybe in institutions that you wouldn't know. For example, the Applied Physics Lab is pretty close to Goddard, so is UMD, where Nick works. So yeah, I would recommend starting with the job postings and just getting an idea of the mapping that goes into it.
I can add to that a lot. There, add a little bit to that idea. There's a lot of possibilities for internships. So like the NASA centers like JPL and Goddard and Marshall, and there's a lot of them, Kennedy. I'm not going to name them all here off the top of my head. Oftentimes we'll have like these summer research internships where you can go work side by side with a NASA scientist on a small topic of research that you might be interested in doing. It might be a little more challenging if you're coming from an international stage to get involved in that kind of work, but usually you have to sort of pay attention to the timelines for that. If you start thinking about a summer internship in May before the summer, it's too late. You gotta like kind of anticipate that there's like a cadence to these things. So be looking around on the web, especially at the different NASA postings if you're interested in a summer internship. But if you're near a university or a small college where there might be a professor there working on it, you can email them and ask, is this something you'd be interested in doing a small project? There might be a research program that they have. In my small school, it was like 1,200 students of undergrads. We had like 5 people in our geology department, right? They had like a summer research at the Keck Institute, which was like funding undergraduate research programs. So it's an opportunity for like us to go study anything we want with a person who I was at one of the partner schools, right? So, it was just being creative and asking questions that kind of open doors for internships. So if you have like a passion and you're working with an undergraduate program, go talk to the professors in the departments that have planetary scientists, or maybe even a geologist or a physicist, and they might even have a science research project that could open the door for your planetary interests. But you have to talk to people. You can't just assume these things will fall in your lap. You have to go out there and find the opportunities.
Yeah, I would add to what Corrine and Nick said that it's important to, depending on where you are in your research career, if you want to go back or not. If it's a one-way commitment, I think there's more flexibility in what you can explore. If you're looking to go back into research by doing something else for a while, then it might be helpful to limit that while to a year or two max, because if you're gone for longer, it just gets harder to get back into the research field. So that's just something to keep in mind, and certainly something I considered when I was doing the NASA IPA. It was a service agreement, and there was a lot of, it's like a contract where I was just doing a lot of service work and programmatic work, and I had to negotiate time to do research during that 2-year window. And I really had to fight for it. Like they give you enough work to keep you more than fully occupied, but it was something that I was really adamant about because I wasn't sure if that was for me. I wanted to try it out for a couple of years, and I was happy that I did that because I ended up not loving it as much as doing research, and it was really good to have invested that time and also not completely severed all my ties with my existing projects. And so, kind of keep that in mind. Same if you want to kind of go into industry, if you want to work, if you want to leave academia and work in industry for a little bit, I think it's more challenging to get back if you do that for a little bit. I think again, more than a year or two, it's more challenging, and there are things you can work out with your academic institute, but try to also assess how much you want to invest in doing that, whether it's tangential or a bit more divergent from what you're currently doing, and seeing if the timing works out for you as well, and your ability to either go back or to stay forward, kind of moving ahead with what it is that you want to do.
Thank you. Thank you. So are there any questions that you wish we'd asked that we haven't asked yet? Something that this topic brought up for you that you'd like to share more on so far? Perhaps something about the challenge of translating your skills. Which ways is it easy to take what you know, what you've done, and apply it, and where is it more challenging, or where did you hit a bump, something you didn't know, something you didn't expect?
If I could share something really personal, it's about the imposter syndrome. I learned that everybody has it, regardless of your gender identification, your race, your ethnicity, and your skills, your educational background. Every single person I've had an honest conversation with has had it at some point or another in their lives, and so I just kind of wanted to share that it's it's common. I think that, and I think it's also just something to kind of be mindful of, that the person sitting right next to you who you think might have their kind of just have it all figured out may not have anything figured out, and just as putting on a really good act to do that because of what other people might be thinking, and so. Just be aware of that. I think that we are all able to contribute something, and we all have our own independent ways of thinking, and I think that just enriches the field in such a beautiful way. And once people start to ask if they can use what you wrote and or what you said in their own papers or what have you, then take that as the biggest compliment. And then not only do you belong, but you're contributing meaningfully, in addition to your own work, obviously, but that other people also are grateful for you.
Yes, thank you for saying that. That's something very important. Hoping to do a webinar at some point on imposter syndrome.
That did remind me, Majd, of what you said earlier of authenticity. Having that shine through is infectious, and you can see it whenever you're talking to someone. So, yeah, I guess that's all I wanted to say about that.
Yeah, I'll second the whole business with imposter syndrome. I question sometimes on my days if wow, why am I in this field? Am I the proverbial dog that caught the mailman's car? Like this is sometimes it's a little, you have to pinch yourself that you're doing things that you never thought you'd be able to do, and then you wonder, am I really the person to be doing this? But you are. You're the person there doing it, right? And the thing about a lot of science and research is that no one else is going to do this, right? It's the passion that you bring to the table, the goals of you set for yourself, right, is really why you're there. So, if you have enough interest to really pursue something and really go after it, right, you're in the right place. You're the person to be doing that job. And that's kind of what I tell myself so that I keep moving forward, right? Like if nobody else is going to just do this because I think it's interesting, you're the one doing it. You're the one who's interested in it. Um, and it's actually a real privilege too. This is something is also planetary science is a privilege, right? We're exploring the universe together as a community, and we're doing that usually on the back of public dollars. And that is an important responsibility. It's the fact that we're safekeepers of this public trust in what we do. So it's on our shoulders to do the best job we possibly can. And that's what I strive for every day is to like, hey, I'm doing something really cool. And it's my responsibility to share that with the people out there in the public, but also to do the best science that we can with that resource. And so it's really kind of this awesome opportunity that we have that, if you think about it, planetary science is a pretty new field. People have been looking up at the stars and doing astronomy and whatnot, but like actually sending things to those planets, putting things in orbit around them, landing on them is just this incredible thing that humanity is doing. And we're part of the first steps in many cases of these things, right? So like it's really kind of cool to step back and sort of see it from that perspective. So like, if you want to get in on this endeavor, if you want to get into planetary science, bring that passion, right? This desire to know more and learn, and also that sort of sense of responsibility is that we're doing these things because people find it exciting, right? And it's your job to sort of help translate that back if you can, right? You can go study some arcane little like system and do your science with it, right? But always turn that around and say, yeah, what is it? Why we're doing this? Why it's important? And why it's exciting to you. I think that excitement, the transfer of excitement is really important. And you saw this again with Artemis too, that they know what they're doing with their science team. They're like asking the astronauts how they feel about it, like what's going on in their heads. And you can see that excitement coming through, right? And sharing that with people, why the science is so interesting and exciting to them, I think is one of the key elements of that. It's just, this is a really cool thing that we get to do. So.
We have another good question here. If somebody is very specialized, right? Because planetary science, astrobiology, very specialized bits and pieces. How can you tell if you're too specialized and you might have a hard time moving from one thing to another. Is it possible to be too specialized where you can't move from one thing to another?
Well, how do you know if you're too specialized? I think if you go give a talk and nobody asks a question because nobody knows what you're talking about, that's a good example. But I think you can be too specialized, and in one way, we're supposed to be, right? If you're getting a PhD in something, it's because you become the leading expert in that little one niche. And if you do it long enough, then as you progress in your career, then you become the world's expert on this one thing. But this one thing gets a little bit broader as you kind of advance in your career. I have seen cases of people who have only studied the ionosphere of Saturn, and they've written so many papers on that and have had a very long career with it, and now they don't know what to do with themselves because they've done everything they think they've thought of doing, and they're having some trouble kind of translating those skills into other planets or other fields. So I think that depends on the individual as well. If you're interested in diversifying, you can look for opportunities where what you've learned can apply to other topics, and it doesn't need to be as far deep in as what you currently are the niche expert in. But if you take a couple of step backs, you'll realize that there's more things that this can apply to, and hopefully your advisors or your networks can kind of be that population that can give you some feedback on that. And it's a starting point if you want to transition into something else. And it's also an amazing opportunity to learn something else. And that's also, I think, one of the best things too.
One of my advisors when I was early on told me to learn about process rather than a specific thing, right? So thinking about systems and processes together, right? So like I see in the chat, Eric wrote he was worried about being hyper specialized in cryovolcanism. Well, cryovolcanism is a form of advection and motion of fluids through an icy shell, for example, right? It's just the material itself is water or some sort of liquid, right? So you can think of that in more broadly the process of how do you get mass through shells or crust, right? So there's a lot of like transferable knowledge about those kinds of processes. Of course, cryovolcanism is a special case where you have water moving through ice, but there's places on Earth where there's water moving through ice, right? So you could use that kind of skill to transfer to glaciology or cryosphere processes on our own planet, right? So like thinking more broadly about what it is that you're studying and how it fits into the bigger picture is something you always want to be doing, right? Like I study seismology, which is a pretty broad discipline, arguably multiple disciplines, right? But like thinking about how it translates to hazards, or how do you do structure or study deep interior, or even just do resource exploration with active source, right? It requires thinking about all these different sort of processes that you can focus in on, right? So, your job as a student is to get the skill sets that will allow you to think broadly about things, but also be able to look at the details, right? So you have to sort of hone both aspects of your research personality, right? If you go off and do a PhD, for example, right, you're going to poke at one little tiny spot in our realm of knowledge and try and expand that outward. But really what you're learning is how to write and how to do research and how to communicate, and then taking those skills and applying them more broadly to the research problems that you're interested in, right? So it's okay if you hyper specialize in the PhD, but you got to also be thinking about what I like to call your final chapter of like, why does this matter? Where are you going to take it? What are your next steps, right? And that takes time. You don't just develop those skills overnight. You have to sit down and really ruminate, right? Take that time to let your brain soak in all the information and think about these connections. So it's not something that just happens. You can't just turn a switch. The best scientists are the ones who've spent a lot of time thinking about the problem, right? And the same thing is with planetary science. It's a lot of different topics. So like, find the ones that are really interesting to you and just soak in that literature, read the papers, talk to people, learn something new, try a new data set, right? Be curious, right? That'll make you the best planetary scientist.
Yeah, I don't have a whole lot to add actually. I'm learning from our panelists as well. But yeah, just to drive Nick and Maj's point home, uh, so first of all, Earth is a planet. I do include it in planetary science, but studying the planets helps our fundamental understanding of Earth, right? And vice versa. It's, studying climate, geology, there's atmospheric sciences, atmospheric dynamics. All of these, um, they reflect on one another, and learning starting to learn with earth sciences, there's a lot more data on a lot of these things. Just the nature of our, continuous earth observing uh, constellation, right? So that's a good, I guess that's a good niche would be a computing, supercomputing especially. But but yeah, a lot of these can be applied to planetary science as well. It's just exactly like Nick said it, I could not say it any better. Learning the process is really what it comes down to.
Excellent points. I'm launching our evaluation because we're at the top of the hour. While I'm here, though, there was a question, and Corrine, thank you, SJ, for responding as well. Corrine, you don't have your PhD yet, and yet you've been actively involved in planetary science for many years. Do you want to talk just a tiny bit about the number of people that you work with, and in terms of who has the PhD and who doesn't?
Yeah, really quickly. I actually only have a bachelor's degree right now. I work full time, but I'm currently studying a master's degree part-time in environmental science and policy. But I I am maybe like one of few people that do what I do that don't have a master's or PhD. But so I don't want to say that those are necessary, but they definitely help build that network, if you will. I feel like I got really lucky with being in the right time and place. So yeah, whatever you see fit, especially if it's a little more niche, you may need a little bit more time to build that network.
Thank you so much. Yeah, so it's possible. It's possible. Anyway, and then there was another question about international students. I've been posting things that I find that are available for international students as well, but does anyone have anything to add to that one? Last question. And Maj, do you specifically have any insight into programs that somebody who is an international student that wants to apply for a master's program, for instance? I don't know if you do or not, because you've got other experiences instead. So
Yeah, I'm not familiar with too many programs, but I would just scour the net to see what's available, and see if there are people I can have a conversation with there before I apply.
thank you. Yeah, I believe that the Division for Planetary Sciences, DPS, has a web page with lists of different programs, mostly PhD programs. They might include master's programs, I'm not sure. And I do have a link to that page from one of our pages, from our page on our news page, the one that has the fellowships and the internships. So news, planetary news for students and for early careers. And so I might have a link from there to the DPS page. I do recommend checking that out. In the meanwhile, we're a couple minutes over. Everyone, please join me in thanking all of our panelists. We're delighted to have them here with us today. Thank you so much for all of you for joining and sharing your thoughts and questions. We're glad to have you and our speakers. And if you didn't get a chance to finish the poll, you'll get an evaluation survey that has exactly the same information.